Hi, Assalamualaikum and a very good morning. So today we're going to do some tutorial discussion for chapter 11 and we're going to focus on the subtopic of 11.4 which is the preparation of amine as well as the subtopic of 11.5 which is the chemical properties of amine. We're going to do tutorial question 5, 6, 8, 9, 10 and 11 respectively. So without any further ado, let us start. So for tutorial question 5, we have to identify A to E in the following reaction. So for the structure of A, we have the CH3 CH2Cl and react with A in order to produce CH3 CH2 bracket 2 NH plus HCl. Okay, so here you have a haloalkane and here you have a secondary amine. Okay, so the secondary amine gonna look something like this: CH2 ethyl group and CH2 ethyl group here. Okay, so you know that the reaction of haloalkane with amine, okay, let's say NH3, which is ammonia, it's gonna react and form an amine. But in this case, because it's gonna give you another ethyl group, so you know that you have one of the hydrogen gonna be changed into ethyl group. Okay, so you can imagine it to be like CH2Cl. Okay, and this is your nucleophile. So your nucleophile gonna attack here, and then the haloalkane gonna break the bond. Okay, and here will causes the N attached with ethyl group. At the same time, the one of the hydrogen gonna be removed because it have H and H here. So H and Cl gonna form together in order to produce HCl, and the balance of one hydrogen gonna attach here. So this is gonna produce the secondary amine as shown here. Okay, so you know that your product here gonna be NH2 CH2 CH3. Okay, so it's gonna be CH3 CH2 NH2, which is the amine gonna be the nucleophile and attack the haloalkane. So it will undergo because it is a primary haloalkane, right? So primary haloalkane will undergo SN2 mechanism. Okay, so it will take and then it's going to break apart and a secondary amine gonna be formed. Okay, so let me wrap off here. So the answer here gonna be CH3 CH2 NH2. Okay, so that's the product of the the reactant for A. Okay, and now for B, we are given CH3 CH3 CH2CN, and it will undergo reduction with lithium aluminum hydride followed by hydrolysis. So you know that this is a nitrile compound. Okay, and the product here gonna have the reactant here gonna have CH3 to the power of 3, which has 3 subsequent, and then you're gonna have CH2CN. So when it undergo reduction, it's gonna become CH, CH, and NH2. Okay, so your B here gonna look something like this. So you're gonna get CH3, 3, CH2, CH2 because of here, and then NH2. Okay, so your B gonna look something like this. Okay, and for the structure for the reaction of C, you are given C, CH3, 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 and then CH, C double bond O, and H2. Okay, and then what you're going to produce here is a primary amine. Okay, and as what you can see here, the CH3 CH3 is basically the same as CH3 2 here. Okay, so it's basically the same meaning. Okay, so it just wanted to trick you. Okay, so basically it's the same meaning and it got the same attachment on the same carbon. Okay, so what changes here is the C double bond O and NH2. So what happened, the difference here gonna happen at here, because the C double bond O gonna become CH2 and the NH2 here gonna maintain. So from the primary amide, from the primary amide, it's gonna produce a primary amine. Okay, so it will undergo reduction. Okay, and for the reduction of amide, we have to use lithium aluminium tetrahydride or lithium aluminum hydride. And then number 2, we need to write hydrolysis, which is H2O. And as mentioned, the amide, we cannot write H3O+. Okay, we just write it as H2O. Okay, this is because the NH2 here is a basic. When there is a base react with an acid, we're going to get a neutralization reaction instead of reduction. So what we need is a neutral solvent, which is water, not the acidified condition. Okay, so the answer here going to be lithium aluminum hydride with water. Okay, and here number 2 here, H2. Okay, and now for D, we don't know the structure, but then we're going to use the catalyst of Sn in the presence of acid HCl in order to produce NH2 and NH2 attached in the benzene ring, which is 2-amino-aniline. Okay, so you know that this is a reduction of nitrobenzene. Okay, so dia mesti datang daripada benzene ring that is attached with a nitro group. Okay, so you can say that both of these come from a nitro, and then it will undergo reduction in order to form this structure here. Or you can say that one is aniline, and then the other one is they're going to have a substituent of nitro. Okay, or you want to change the position also can. Okay, so there are going to be two possibilities here because the nitro group can be reduced into amine. The nitro group can also be reduced into NH2 here. Okay, so there are going to be two possibilities. So the first structure here can be NO2, NO2. Okay, and the second possibilities that you can get is NH2 or NO2 here. Okay, because both, it can be only one of that is being reduced to NH2. Here it will not undergo any reaction. Or you can also change the position, doesn't matter. Okay. Alright, so that's for D. It will undergo reduction of nitrobenzene. And now for the structure E here. So we are given the CH3 C double bond O NH2. So here refer to a primary amide. So primary amide. And now as what you can see here, at first you're going to have 1, 2, 3 carbon, but here it's going to have 2 carbon. So you know that it will undergo Hofmann degradation. Okay, because the Hofmann degradation will remove C double bond O, and the CH2 going to attach directly with NH2. Okay, and the reagent for Hofmann degradation, you're going to use bromine, and the solvent here can be NaOH. Okay, and maybe you can also say it to be KOH here. Okay, but you might also be thinking, sir, can I use Cl2 and NaOH here because this is written in the lecture note? The answer here is no. This is because you know that your byproduct here have bromine, so you have to use bromine either in sodium hydroxide or in potassium hydroxide. Okay, and let's say here I'm going to choose, and for this one I can only choose it using NaOH because I'm producing Na2CO3 here. Okay, so I know that my solvent going to be NaOH and my atom here going to be bromine molecule. Okay, so there's only one answer here, which is bromine in NaOH, and it will undergo Hofmann degradation. Alright, now we move on to the next question, which is tutorial question 6. So based on the reaction below, we have to draw the structure of J, K, L, M, and N. Okay, so the structure J here. So this is our given structure, which is a primary or secondary amine. Okay, and to make it easy, and HCH3, I draw it like this. The other balance here, I'm just gonna write it as R, because the R here gonna be still the same, because the reaction only happened at the functional group of amine here. Okay, so the big thing here, I'm just gonna label it as R. Okay, but for the answer, you need to write it again lah. Alright, so it's just to make things easier to explain. Okay, so now we have NHCH3, and then it will undergo reaction with NaNO2HCl. So NaNO2HCl here refers to the nitrous acid test. Okay, for the nitrous acid test, if we're going to produce the HNO2 in situ, maksudnya the HNO2 here can be prepared directly daripada reaction of NaNO2HCl dekat low temperature, which is 0 to 5 degree Celsius, and we're going to produce our nitrous acid. Okay, and the nitrous acid here, which is HNO2, we can also write it as HONO. Okay, so HNO2 sama juga dengan HONO. Okay, why do I do it like this? This is easier so that you can see how the bond is formed. Okay, so kat sini pun I can change my position. For example, let's say I want to put my CH3 here, and my hydrogen gonna be here. Tak jadi masalah because it's still the same. Okay, and I'm gonna react that with my HONO, which is my nitrous acid. And what I can see here is that the HOH here can be eliminated as a byproduct of water. And then my N and NO here going to be forming. Okay, so it's going to form N double bond O, and then here is CH3, and the balance there R. So R ni adalah baki tadi. So you need to write back CH, atas dia CH3, CH2, and the benzene ring. Okay, so I know that this is the part that is important, which is the reaction of a secondary amine with the nitrous acid test. Okay, secondary aliphatic amine, and what I'm going to produce here is a nitrosamine. Okay, which is a yellow oil. Okay, this one you can check back in your lecture note. Okay, so what important here is this one. Okay, which is N-N double bond O and CH3. Okay, sama maksud saja. And then the R is copy back again. Okay, so that's for J. Now we're gonna do our M here. So K. Okay, so we can do K here. So for the K here, we have our CH3Br. Okay, so for our CH3Br, what you're gonna do here is that the CH3 this one is a Grignard reagent. This one is haloalkane, and haloalkane can react with amine, okay, in order to produce amine, which is a secondary amine here. Okay, so this one is a primary amine. Okay, so what's going to happen here is that, let's say if you have your CH3Br, and then I'm going to react that with my R, and then NH2 kat sini. Okay, so what's going to happen, my lone pair gonna attack the carbon, and the Br here gonna remove. So one of the hydrogen here gonna be removed in order to react with the bromine in order to produce HBr. Okay, and N akan attach kepada CH3. So R and satu H tadi dah hilang pasal dia buat dengan bond dengan Br, so you're gonna have H and then CH3. Okay, so you know that my here is equivalent to here, and HCH3 and HCH3, and the R group here is still maintained. Okay, so you know that my initial of K here gonna be a big R group here but attached with NH2. Okay, so my structure here gonna be R and H2. Okay, untuk jawapan tulis semua. Okay, then this one is just to make explanation easier. Okay, so that's for the structure of K. Okay, so now I'm gonna proceed and do L. Okay, so for the structure of L here, kita ada the same structure, and then we're gonna react that with the Hinsberg reagent. So for the Hinsberg reagent, you need to know the structure of the benzene sulfonyl chloride, which is benzene sulfonyl chloride. Okay, so as mentioned in the lecture, the benzene sulfonyl chloride going to be a benzene attached with SOCl. Okay, and what going to happen here is that this one is a secondary amine, right? Okay, so a secondary amine, I'm going to draw it again, hydrogen, CH3, and my R big group here. So H and Cl here can be removed in order to produce HCl, and then the NS bond can connect together. Okay, so kita akan dapat NCH3 bond with S double bond O, and the benzene ring, and the R just copy back again. Okay, so you're gonna get something like this. Okay, so this one is the R group, and then NCH3, and then N gonna form bond with S double bond O, benzene, the benzene group here. Okay, so that's for the structure of L. And then I'm gonna do the structure, the next question, which is M. Okay, so M, we're gonna have your R and H and the CH3 here, which is this big structure here. Okay, it's the same. And then you're gonna react that with the C double bond O, CH3, OCl, and CH3. Okay, so what gonna happen here is that it gonna forming an amide. Okay, so this one is a carbonyl group or an acyl chloride. So here gonna attack here, and this gonna causes this one to go up, and then this one is the mechanism, but then you don't have to know, but at the end it will push the chlorine out. Okay, and the hydrogen here will also be removed to attach with the Cl in order to produce HCl. Okay, so what you're gonna get at the end is your R group and C double bond O, CH3, and then your CH3 here. Okay, and the H and Cl here gonna be eliminated as the byproduct of HCl. Okay, so what you're gonna form is an amide here. Okay, so it's gonna look something like this. Okay, and C double bond O, CH3, and then the CH3 there. Okay, yang lain adalah R, which is we just copy back again from the question. Okay. Okay, ini adalah reaction yang mana satu nucleophile and satu is electrophile. Okay. And now we're going to do question N. Okay, So untuk structure N, we have our amide here. So from M that we have drawn, so it will undergo, okay, this one is known as the primary amide, okay, and then it gonna be reduced into N. So it uses lithium aluminium hydride followed by H3O+, yang sepatutnya adalah H2O, because lithium aluminium hydride, for the primary amide, it can only be reduced into amine using a neutral condition H2O, not H3O+. Okay, tapi dalam soalan kadang-kadang they will still maintain it that way. But for a proper way, it's better and safe to use H2O. Okay, so what happened here? It will undergo reduction, yang mana C double bond O gonna become CH2. Yang lain copy sahaja. Alright, so for the structure of N here, we're gonna get NCH2 because of reduction, and then CH3. The other you just copy back again. Okay, so these are the steps in order to find out J, K, L, M, and N. Okay, it might be a little bit difficult for you at the initial stage, but yeah, you can use the R in order to simplify, and untuk jawapan akhir tulis balik lengkap. Okay, so that's for question 6. So for tutorial question 8, we have to show how each of the following compound can be synthesized. So we need to synthesize 2-methyl 1-propanamine from 2-propanol. So the 2-propanol gonna have 1, 2, 3 carbon, and then the OH group gonna be attached at carbon number 2. Okay, so this is 2-propanol. And then we're gonna synthesize 2-methyl 1-propanamine. Okay, so propanamine will have 3 carbon, which is 1, 2, and 3, and then it's gonna attach with amine group, which is NH2. Okay, and then it's gonna have methyl at carbon number 2. So this one gonna take now carbon number 1, carbon number 2, and carbon number 3. And because the carbon that is attached with NH2 gonna take number 1. So at carbon number 2, it's gonna attach with the methyl group CH3. Okay, so as what you can see here, initially you have 3 carbon, and now you have 4 carbon. Okay, so from 3 to 4 carbon, you know that the reaction that can add the carbon chain only have 2, which is Grignard reagent or the cyanide compound or the nitrile compound. And we're going to use the nitrile compound because it is easier for the nitrile compound in order to be reduced in order to form amine group. Okay, so we know that we need to produce a nitrile compound first before it is being reduced in order to add the carbon chain. Okay, so you can draw using a skeleton structure, or you can also use a condensed structure. So let's see if I were to draw it nicely here, which is a 2-propanol, 1, 2, and 3. So OH is attached to carbon number 2. So the OH group here, I can change it into chlorine first in order to produce haloalkane. So from alcohol, I'm going to use SOCl2, or you can use PCl3, or you can use PCl5, doesn't matter. And the OH here going to be replaced with Cl. Okay, so you're going to produce a haloalkane. Okay, and this haloalkane can now react with NaCN in ethanol. Okay, so that the Cl here can be replaced with Cn, so that you get your nitrile compound here. Okay, so you can use NaCN in ethanol. So what's going to happen here is that the Cl going to be replaced with Cn. Okay, and the Cn here, we can change it into amine group by undergoing reduction with a reducing agent. For example, I'm using the sodium borohydride in methanol, or I can also use lithium aluminium hydride with hydrolysis, which is H3O+. Okay, untuk nitrile compound, we can use H3O+, but for amide, for example like this, we can use lithium aluminium hydride, tetapi water. Okay, there is a difference. This one is nitrile, so you can use H3O+. Okay. Okay, so let's say if you want to be safe, you just wanted to use NaBH4 CH3OH, which is a methanol. This part here going to be reduced into CH2 and H2, and the others will be just copied back again. Okay, so you're gonna get 1, 2, and 3. So this is gonna get your propanamine, and then at carbon number 2, which is 1 propanamine, and at carbon number 2, you're gonna be methyl group. So this is how you're gonna synthesize 2-methyl 1-propanamine from 2-propanol. Okay. Now let us look into tutorial question B here. So for tutorial question 8B here, we have to produce a secondary amide from benzene. Okay, daripada benzene yang biasa. Okay. So from benzene, you have to add 1 carbon chain, and then you need to add NH2 here. So how can you do that? Okay, so we have to use our knowledge from chapter 6, which is the chapter of benzene and its derivative. Okay, in order for us to add the carbon chain, okay, we can use Friedel-Crafts alkylation. Okay, so let's say I'm having my benzene here, and then I'm going to undergo Friedel-Crafts alkylation where I'm going to use AlCl3, and here supposed to be CH3Cl, because I want to add up one carbon chain here, which is to become a methyl benzene, and then this methyl benzene here can be oxidized in order to form benzoic acid. Okay, so tak kisah panjang mana sekalipun, the carbon chain here going to become benzoic acid. Okay, C double bond O, OH here. So as what you can see, it's almost near to the product that you wanted. Okay, and next what we can do is we can react that with a amine group, which is the methylamine. Okay, so why we're going to use methylamine? Because we have NCH3H here. So the NHCH3, okay, so this is going to act as a nucleophile, and then the C double bond O here gonna go up. Okay, this is kind of mechanism, but you don't have to know. But at the end, the OH group gonna be eliminated. Okay, so it's gonna go up, go down balik, akan jadi double bond, and then OH gonna be removed. And as a result, what you can see here is that your benzene ring gonna be attached with C double bond O and H CH3. Okay, dan OH tadi yang negatif tu, dia akan ambil one of the hydrogen from the N group here. Okay, so here going to break apart in order to form byproduct of water as well as the amide group of benzene, C double bond O and HCH3, like this. Okay, so it's going to become benzene ring attached with C double bond O, NCH3 and H. So this is how we're going to prepare this secondary amide here from benzene. Okay, so that's all for tutorial question 8. For tutorial question 9, we have to suggest a chemical test in order to distinguish between aniline and benzamide. So aniline is basically a benzene ring that is attached with an amino group. Meanwhile, for benzamide, it's basically a benzene that is attached with a amide group, which is C, O, and H2, or you can draw it as benzene ring, C double bond O, NH2, which is this refers to the amide group. Okay, so now we're going to compare, or we're going to suggest a chemical test for both of the aniline as well as the benzamide. Okay, so you know that they're going to be a special identification test for aniline, so you can use that as the identification test where you're going to do the reaction with bromine water. So aniline, when it is react with bromine in the presence of water as a solvent, what they're going to do is that the bromine going to attach at carbon number 2, at carbon number 4, and carbon number 6, which is 1, 2, 3, 4, 5, 6. As you know that the NH2 here is the ortho para director. Okay, so you're going to attach here, and attach here. Okay, and as a result for that, it's going to create a precipitate which is 2,4,6 tribrominoline, which is a white precipitate. And as for the observation, you can say that the reddish brown color of the bromine molecule going to break apart, and then the reddish brown color going to get decolorized. And the second observation, we can say that the white precipitate going to be formed. For the benzamide, when we react with bromine in the presence of water, there are going to be no observable changes. So for the observation, we can say that the reddish brown color of bromine remains unchanged. Okay, and now for question 9b, we have the ethanamine. So ethanamine going to have a structure of CH3, CH2, okay, and then they have NH2 because one of the hydrogen of the ethane going to be changed into amine, so it's going to be ethanamine. Meanwhile, for N-diethyl ethanamine, it's basically the same as this one, which is CH3, CH2, and H2. However, one of the hydrogen or two of the hydrogen going to be changed into ethyl. So ethyl group 1 and ethyl group 2. So it's going to be N-diethyl ethanamine. Okay, so that's the structure that we have. So we have the ethanamine and we have N-diethyl ethanamine. Okay, so here can also be changed into a skeleton structure of like this, or you can also write it in terms of the condensed structure here. Okay, so in order to differentiate between ethanamine and N-diethylamine, the best thing that you can do is to look at the class of the amine. So the class of amine here is a primary amine. Okay, and here is a tertiary amine. Okay, and both are aliphatic. Aliphatic amine, and here is aliphatic amine. Okay, so the best reaction that you can do is you can do two tests, which is Hinsberg test and also nitrous acid test. So you can choose either one. Okay, so for me, I will use the nitrous acid test. So when using nitrous acid test, you know that you will be forming HNO2. So you cannot write HNO2 straight away, but instead you need to prepare that in situ. So what you're going to do is you're going to react with the sodium nitrite in the presence of HCl, and this need to happen at a very low temperature, which is at 0 to 5 degrees Celsius. So the temperature here is compulsory. Okay, and as for the byproduct of the reaction, because you know that it's a primary amine, and as what you have learned in lecture, what they're going to form first is they're going to form a CH3, CH2, and triple bond N plus and Cl minus. Okay, and you know that it is very unstable complex here, and therefore the nitrogen gonna come out in order to produce nitrogen gas, and as a result they can form alkene, haloalkane, and also alcohol. Okay, so they can form an alkene, alcohol, which is CH3 CH2 OH, because they can take up from the nitrous acid, and then haloalkane, which is CH3 CH2Cl, as well as the nitrogen gas. Okay, and for your answer, you can straight away write down all the four answers here. So this one is just the extra explanation or the intermediate in the middle. Okay, dekat fasa pertengahan sebelum menghasilkan produk. Okay. For the tertiary amine, we can also react that with a sodium nitrite. Okay, and for the observation, we can say that the nitrogen gas gonna be released even at a very low temperature. So this is an important observation because we are talking about the bubbling of gases that indicates the nitrogen gas. Okay, and for the N-diethyl amine, which is a tertiary amine, we're gonna react that using a similar nitrous acid test, which is NaNO2 in HCl at low temperature, and what we're going to produce is a tri-ethylium ethyl ammonium ion. Okay, the triethyl ammonium ion gonna be a very soluble salt, and because it is very soluble, what we're going to see is a clear solution. Okay, clear solution, or you can say that a colorless solution going to be formed, and there is no formation or no gas bubble going to be released. Okay, and the naming here is not that important as long as you draw the structure correctly. Okay, now for tutorial question 10, when a compound with a molecular formula of C7H9N was treated with Hinsberg reagent and nitrous acid, which is HNO2, respectively, the following result were obtained. So when the amine here, C7H9, react with KOH under the Hinsberg test, which is the step number 1 here, they're going to produce a clear solution. For step number 2, they're going to produce a precipitate, which is a white precipitate. Okay, so you know that it is a primary amine. Okay, so this is the indicator here, because as what you have learned in your lecture, we're going to see the primary, secondary, and tertiary amine, right? And in the summary table, I've shown you about the summary, which is the primary amine. If in step 1, they're going to produce a clear solution. In step 2, they're going to form white precipitate. If secondary amine, kita akan form white precipitate dengan white precipitate. Kalau tertiary amine, we're going to form a clear solution and clear solution. So for in this case, it is clear and white precipitate. So we know that it is a primary amine. Okay, cuma we doesn't know whether it is a primary aliphatic amine or a primary aromatic amine. So we have to look at the next test here, which is the nitrous acid test. So for the nitrous acid test here, they will know production of the nitrogen gas below 5 degrees Celsius. Okay, so for this observation, it refers to the aromatic primary aromatic amine. Okay, and the summary of the nitrous acid test can be seen here. So for the primary aliphatic, the gas bubble gonna be evolved. Similar to what you have looked in the previous question. Okay, and for the primary aromatic, there gonna be no gas bubble evolved unless it is being heated. So you know that it is a primary aromatic amine because of the situation here. Okay, okay, so you can look again at your lecture note. Okay, so now we have a structure of C7H9, and you know that it is a primary aromatic amine. Okay, which is a primary. Okay, so now you need to be able to predict the structure. So you can try an error. So let's say C7H9. So you might at first, because you know that it's an aromatic amine, so you already know that it's gonna contain a benzene ring. Okay, so you're gonna have 1, 2, 3, 4, 5, 6 carbon, and then you can form an aromatic amine where you can put food and H2 here. Okay, so if you were to count the number of carbon, you're gonna get C6. Okay, and then hydrogen, you're gonna get 7, because 1, 2, 3, 4, 5 add up with 2, and then nitrogen, you're gonna get 1. Okay, but what you need is C7H9N. So you are lacking CH2. Okay, so you know that you need to make a substituent of CH3. Okay, so you can make a CH3 here in order to complete the C7H9 here. Okay, so you can count back where you have 1, 2, 3, 4, 5, 6, 7. So carbon got 7. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9. And then nitrogen got 1. Okay, so this can be your answer for the compound with a molecular formula of C7H9 here. Okay, so and that is why they asked us to draw one possible structural formula. So maybe one of our possible structural formula going to be this one here. Okay, and it's not necessarily to put the CH3 here. You can also put it here, or you can also put it here. Okay, so you can say that your structure here can be like this, which is at the end here, or you can also put it at the CH3, you can also put it here, or the CH3 also you can put it at the second carbon. Okay, so there are three possibilities. Okay, and do not mistaken it to be like this. Okay, some people gonna thought that it's gonna be NH2 here. Okay, so for this one, the carbon gonna have 7, which is 1, 2, 3, 4, 5, 6, 7. The hydrogen gonna get 9 because 2 plus 2, 4 plus 5, 9 and N. Okay, here it is a wrong structure because it is not aromatic. Okay, it needs to be, the amino group need to be attached directly to the aromatic ring, then only it is called aniline, or else this is known as aliphatic. Okay, so you really need to be able to understand what is meant by aromatic amine, where the amino group attach directly to the benzene ring. Okay, bukannya di rangkaian karbon kat sini. Okay, so by understanding that, we can further proceed with the next question here. Okay, so we have three possibilities here, which is 1, 2, and 3. Okay, so I just focus on one answer here. Okay, tapi if you jawab this one or this one, it is still correct. Okay, sebab dia hanya nak satu lah. Okay, and then we have to write all the equation that are involved. So for the Hinsberg test, what we're going to do is we're going to react our aniline. Okay, so I'm going to put it on the, okay, sejadikan dia sebagai horizontal, jatuhkan dia ke sebelah kanan. Maksudnya dia jadi beginilah. Okay, CH3. Okay, if you want to make it still upright pun tak jadi masalah. Okay, it's just me wanted to make it left hand side so that I can jimat space. Okay, so as long as the number is correct, which is 1, 2, 3, 4 and 1, 2, 3, 4, then it is okay. Okay, so that is why I'm doing the secara melintang. Okay, so as what you can see here, the primary aromatic amine or aniline gonna react with the Hinsberg reagent. So the Hinsberg reagent is the benzene sulfonyl chloride, where the benzene gonna attach with S double bond O and Cl here. And what gonna happen is that, let's say if we expand the structure here, which is NH and another H here, so what gonna happen is that the Cl and hydrogen gonna be removed as the byproduct, and this happens in the presence of KOH, where the K here gonna replace the hydrogen here in order to form K plus. Okay, so what we're gonna produce is that the NS bond gonna be formed. At the same time, the H here gonna be replaced by K plus here. Okay, and this is a soluble salt. So when it is soluble, means that it's going to dissolve in the solvent, and hence we can see a clear solution. And that is why in step number 1, which is the addition of KOH, a clear solution is formed. And now we're going to acidify the mixture here using HCl. Okay, so here refer to the step number 2. Okay, here is step number 1. Okay, for the step number 2, the HCl, the H here can be used to in order to replace back the K plus here, so that they can form NH bond, and the K plus here going to react with Cl to form KCl as the byproduct. But the byproduct here is not that important. What's important is the amine product here. Okay, so what you're going to get at the end is the NH bond here, and then this going to form a white precipitate, which is insoluble in water, mendahkan putih. Okay, so this one is for the Hinsberg test. Now we're going to look into the nitrous acid test. So for the nitrous acid test, I'm going to copy back the structure here. And then what I'm going to do is I'm going to react that with NaNO2, which is sodium nitrite, in the presence of HCl at low temperature in order to produce nitrous acid in situ. Okay, secara terus. Okay, and what's going to happen here is that I'm going to form N triple bond with chloride, and this is a very stable salt known as the arene diazonium chloride salt. Okay, and this is can be used in order to form dye. Okay, so it is a very stable salt and it can be used in order to form dye. Okay, and here you're going to see that there is no nitrogen or no bubble gas is formed, where the bubble gas here refer to nitrogen, unless it is heated. Okay, so the same observation as what you can see in your lecture note, which is no gas bubble evolve unless heated. Okay, so that's for tutorial question 10. For tutorial question 11, we have to arrange P, Q, R, and S in the order of increasing basicity and explain your answer. So as what you can see here, the P here is an aromatic amine or known as aniline. Meanwhile, Q, R, and S are known as the aliphatic amine. Okay, and for S, it's gonna be a tertiary amine because the nitrogen is attached with 3 alkyl group, so it's gonna be a tertiary amine. And for R, it's gonna attach with 1 and 2 alkyl group, so it's gonna be a secondary amine. For Q, it's gonna be attached with 1 alkyl group, so it's gonna be a primary amine. Okay, and we're gonna arrange that in the order of increasing basicity. So we can say that the structure S here is the most basic because it has the most alkyl group, followed by R, followed by Q. And then P gonna have the lowest basicity because the electron is being delocalized in the benzene ring. Okay, so let us explain that in words. So what we can say first is that Q, R, and S are basically aliphatic amines. Q is a primary aliphatic amine, R is a secondary aliphatic amine, and S is a tertiary aliphatic amine. Meanwhile, P is an aromatic amine known as aniline. Okay, and in the increasing order of basicity, we can say that S gonna be the most basic, followed by R, followed by Q, and then followed by P, which is the least basic. Okay, S here is the most basic. Okay, and as for the explanation, we can say that S have the most alkyl group, followed by R and Q, and the alkyl group here gonna act as an electron donating group. So it will donate more and more electron density towards nitrogen, and hence make the nitrogen more negative. And it will have the most electron density on the nitrogen atom. So the extra negativity around the nitrogen make the lone pair more attractive towards the hydrogen ion. So bila dia makin negatif, dia lagi mudah nak ambil hydrogen. Okay, so bila dia lagi mudah nak ambil hydrogen, it means that it's gonna have a higher basicity. Okay, and the aniline here, which is the P, is the least basic due to the delocalization of the lone pair of the nitrogen in the benzene ring, and make it less available to accept a proton. Okay, so I think that's all for today's video. See you again some other time. Bye.